The cure for an ailing Torqueflite can be as simple as a fluid level adjustment or as involved as a teardown. But as you know, finding the correct remedy can be a problem when information about the condition is sketchy. A good description of the trouble gives basic guidance, but the additional knowledge that the condition came on gradually or happened suddenly after other work was performed can make the problem easier to solve. Unfortunately, repair order instructions are sometimes vague, and the customer's version of the trouble can be misleading, so you could have to do your own detective work. You may recognize the reported condition from past experience, but where there is any doubt, first check the fluid and linkages, then run a road test, and if necessary, make pressure tests before you consider opening the transmission. Checking the fluid and linkages first eliminates them as possible trouble sources. But if the road test results are not conclusive, pressure tests in the shop may be needed to pinpoint and verify the trouble. Now, let's see how all this works out. The fluid level is okay if it's between the full and add 1 pint marks, with the engine at idle speed, the transmission at operating temperature, and the selector in neutral. We check fluid level with the engine running and the transmission warmed up so the hydraulic circuits will be filled and the fluid fully expanded. And we can be more certain of an accurate level reading in neutral because the torque converter fills too slowly in the park position. Incidentally, after a drain and refill, the selector should be shifted through all positions so the hydraulic circuits will be full when the level is checked. The importance of maintaining the correct fluid level can be seen in your service manuals, where incorrect fluid level is given as the possible cause of 12 of the 21 trouble conditions covered. Low fluid level can be a general troublemaker because it allows the pump to take in air along with the fluid and results in low system pressure or slow pressure buildup. The effects of air in the fluid can be felt in delayed clutch engagement when you shift into drive or reverse. Air bubbles also cause upshift slipping and pump whine. The slipping, which results from low fluid level, causes overheating and severe wear of clutches and bands. A low level can also cause rapid wear of other parts by starving the transmission lubricating system. Now, when the fluid level is too high, the gears churn up foam, which results in the same sponginess and slipping produced by a low fluid level. In either case, air in the fluid and overheating can produce a sticky varnish coating on valves, pistons, and other moving parts. Varnish should be suspected when the dipstick does not wipe clean and can be verified by dropping the oil pan for inspection. You may also find sludge deposits if water, glycol, or other contaminants have entered the transmission. Where you find only a trace of varnish or sludge and no serious operational problems are reported, a fluid and filter change may be all that's needed. However, a heavy deposit of varnish or sludge is bad news and calls for a complete teardown and cleanout. Any good degreaser solvent will remove the deposits. And don't forget that a transmission cleanout must also include the torque converter, along with the transmission cooler unit in the radiator and the connecting lines. Milky fluid on the dipstick is usually a sign of a coolant leak, possibly at the cooler unit in the radiator. Since coolant rapidly forms sludge and varnish and causes seals and friction material to deteriorate, this condition calls for complete reconditioning. In normal use, the original fluid should not require changing during the life of the vehicle. But for trailer towing or in taxicab, police, and other heavy-duty service, the fluid and filter should be changed as specified in the service manual. The Dexron-type fluid used in Chrysler-made transmissions normally tends to darken with use, so fluid condition should not be judged by the color. When adding to or refilling a transmission, be sure to use only Chrysler-approved Dexron-type fluid. Type F fluids can cause harsh shifting in a Torqueflite, so don't use this type under any circumstances. Now, assuming the fluid is okay, the selector linkage and throttle linkage adjustments should be checked and reset if necessary. That way, you won't have to consider them as possible trouble spots when you road test the transmission. In neutral, the selector lever detent should position the manual valve so that both the drive and reverse ports in the valve body are cut off from line pressure. If the linkage is not properly adjusted, it positions the valve off-center, opening one of the ports to line pressure. This can cause creeping or clutch slipping, depending on how far the valve moves. Checking the selector linkage adjustment is easy. With the engine stopped, move the selector lever slowly until it drops into the park notch of the shift gate. If the starter operates at this point, park position is okay. Next, move the selector lever slowly toward neutral and stop when the neutral detent bottoms. If the starter also operates at this point, you know the selector linkage is properly adjusted. Now, with the selector linkage checked out, you can move on to the throttle linkage. Here, the linkage setting determines the transmission throttle valve position, which, if not correct, affects shift quality. Where the linkage length is too short, the transmission throttle valve opens less than normal, so throttle pressure is relatively low. Upshifting can be early, and there may be some engine speed flare-up during the 2-3 upshift. You can suspect a short throttle linkage setting if you get an upshift flare-up with very light acceleration, but no flare-up under heavier pedal pressure. A short setting can also prevent full throttle kickdown action. In the opposite direction, linkage that is extended too far opens the throttle valve more than normal. As a result, we get high throttle pressure, which delays upshifts and makes them harsh. High pressure also makes part throttle kickdown operation very sensitive. Engine performance is directly related to throttle linkage operation. If engine output is below par, the gas pedal must be pushed down farther than normal to make up the deficit. The added pedal movement moves the throttle valve more than normal, so you get the delayed and harsh upshifting that is typical of an extended throttle linkage setting, even though the linkage is set correctly. Now, let's talk about road testing. Basically, this consists of running through the selector ranges to compare operation with known good performance. Be alert for shifting variations and note the upshift-downshift speeds. You may find a diagnosis checklist handy to record your findings for later analysis. Shift point figures and pressure test results both provide valuable troubleshooting clues. In any case, this information should be available if you need factory help in diagnosing a tough one. Slow acceleration from a standstill in all ranges or poor top speed performance are signs of torque converter problems. If you suspect trouble in this area, run a converter stall test before you go any further. Slipping or engine flare-up in any gear may mean clutch, band, or overrunning clutch trouble. When only one clutch or band slips, it's fairly easy to identify because clutch engagement and band application combinations are different in each range. Now, let's see how it's done. In D position, the vehicle gets underway in breakaway low and then upshifts to second and direct drive. The 2 position follows the same pattern, but upshifts only to second. The 1 position is limited to low gear. In D and position 2, the rear clutch engages. Here in breakaway low, the overrunning clutch holds during acceleration, but releases on deceleration. So there's no engine braking below second gear in either position. In position 1, the rear clutch also engages. In this case, the low and reverse band applies and holds the transmission in low gear, assisting the overrunning clutch when accelerating and providing engine braking when decelerating. In a normal 1-2 upshift, the overrunning clutch simply overruns when the kickdown band applies to cause the shift. Now, on a simplified version of the service manual clutch and band chart, you can see that the rear clutch is engaged in both the D and number 1 positions. If you get slipping both on breakaway low and in position 1, the rear clutch is the probable cause. But if there is slipping only during light acceleration in breakaway low but not in position 1, the overrunning clutch has failed. In a normal 1-2 upshift, the rear clutch stays on and the kickdown band applies. Here, if the transmission does not slip in breakaway low but does slip in second, the cause is at the kickdown band and not in the rear clutch. When the kickdown band slips badly or does not apply at all, the upshift will skip second completely. When that happens, the overrunning clutch holds from breakaway low until car speed is high enough for a shift to direct drive. If there is only a slight kickdown band slip, it can cause a short upshift delay with a thump and a harsh shift as the kickdown band takes over from the overrunning clutch. Another condition to watch for is an engine flare-up during the 2-3 upshift, but no apparent slip in direct drive. This can mean that the throttle linkage is too short or that the front clutch is starting to fail. Now, returning to our simplified chart, you can see that the rear clutch is engaged in low, second, and direct, but the front clutch engages only in direct. From this, we can deduce that if low and second operate okay, but they're slipping in direct drive, the cause has to be in the front clutch. And we can follow the same logic for the reverse setting. In this position, the front clutch and the low and reverse band are applied. If there's no slipping in direct, but you do get slipping in reverse, the low and reverse band is the probable cause. Now, if there's engine flare-up on a full throttle 3-2 kickdown, band adjustment may be the answer. But when you get this condition during a 2-3 upshift, the cause could be front clutch slipping as a result of short throttle linkage or low system pressure. Which brings us to the need for pressure tests. After all, if clutch and band failure results from low system pressures, new parts will also fail rapidly unless correct pressures are restored. Besides, pressure tests give us valuable clues about conditions which cause erratic operation. When line pressure is low, the transmission slips in all forward speeds. The low pressure can result from low fluid level, leaky seals, low pump output, or a clogged filter. In some cases, replacing the fluid and the filter will do the trick. With the selector in the D position, kickdown servo release pressure should follow line pressure closely, as engine speed is raised and reduced to the checkpoint. Low pressure can indicate a leak at the front clutch seals, at the reaction shaft support seal rings, or at the kickdown servo rod guide. If the tests show that kickdown servo release pressure is okay, you can check the low and reverse pressure. A leak in the low and reverse servo can cause low pressure and slipping in reverse. A sticky governor valve can make governor pressure lower or higher than normal. Low governor pressure delays or prevents upshifting. High pressure causes early or erratic upshifting and will prevent normal downshifts. And that's essentially what it takes to check out a Torqueflite transmission. There are other clues that you'll notice as you go along, but this procedure should help you take care of most jobs. Of course, there's more on symptoms and cures in the reference book. And don't forget that a little digging in the service manuals will locate most of the answers to your Torqueflite troubles.